Question 9. Which equation represents a termination step? So immediately it's D, because you have to have two radicals coming together in a termination step. And on the left hand side, A, B and C don't have two radicals coming together as two reactants. So your answer is D. Question 10. Which is correct about the molecules shown below? I know D is definitely correct. Potassium cyanide in a nucleophilic substitution reaction. I know Cn- uses a lone pair on a carbon to react with aldehydes. It will react with the delta plus on that C. Electrons will move on to the O, and that will form O-, and a lone pair of electrons on the O will then react with H+, because this KCN will be in something like acid or methanol. So I know D is definitely correct, so I know D is the answer. Let's work out why A, B and C are not correct. It reacts with HBr in an electrophilic substitution reaction. No, it's electrophilic addition across a double bond. It reacts with NABr in a nucleophilic addition elimination reaction. Now you get addition elimination reactions when you have acyl chlorides with COCl, not aldehydes. It reacts with ethanolic potassium hydroxide in an elimination reaction. It would have to have something to release. So say for example in an elimination reaction it's with something like a haloalkane where it might attack an H, and then the H would move the electrons into a bond and release maybe the Br. I suppose it's possible KOH in an elimination reaction, the OH takes an H off there and the electrons go into here. No, the Br isn't adjacent to the CH3. So if the OH- attacked that H and took that off as H2O, the electrons from the CH would go into this bond here. So the C would have to be adjacent to a Br, so that C there would have to have a Br. No, C is incorrect. D is your answer. Which statement is correct about both 2-methylbutan-1-ol and 2-methylbutan-2-ol? So I've drawn 2-methylbutan-1-ol and 2-methylbutan-2-ol. They can both be formed by the hydrolysis of esters. That's possible. An ester, COOH, could be broken by hydrolysis, adding water back in to break up the ester back into a carboxylic acid and an alcohol. Alkaline or acid can catalyze the hydrolysis, the addition of water back into an ester to create the carboxylic acid and the alcohol, so that's possible. They can both be oxidized by a reaction with potassium dichromate. Well, that would form a ketone there. Well, it can't do that, so you can't oxidize a tertiary alcohol, because if that carbon formed a ketone, that carbon would have 5 bonds. Both be formed by the hydration of methylbutyene. Let's think about methylbutyene. Butyene, it's got a double bond between carbons number 2 and 3. So the hydration is adding an H and an OH. Now the OH could go into carbon number 2 or carbon number 3. If the H and the OH added across the double bond, it would never form the OH. So if the double bond were here in methylbutyene, so if it was CH3C CH3 with a double bond here, the OH could go onto carbon number 2, or it could go onto carbon number 3 when you dehydrate it with an H and an OH, so that if there's a double bond there, the H could go on here and the OH here, or the H here and the OH here, but at no point would the OH appear on carbon number 1. They both have 4 peaks in their carbon NMR spectra. No, with that methyl group being offset, we're going to have 1, 2, 3, 4, 5 peaks in this one, and with that being offset, 5 peaks in each. Now your answer is A. Solutions of two compounds W and X react together in the presence of a soluble catalyst Y as shown in the equation. When the concentrations of W, X and Y are all doubled, multiplied by 2 that is, the reaction increases by a factor of 4, increases 4 times. Which is a possible rate equation? Well, if W doubled, multiplied by 2, 2 2's are 4, and multiply, and x doubled to twice as large, that would increase 4 times, that would increase 2 times, that would increase by 8, not by 4. Again, this one would increase by 4 times, that would increase by twice. 4 times 2 is 8 times. Oh, this one looks good. C, if that doubles and that doubles, so times is by 2, times by 2, 2 2s are 4. C would work for me. What's wrong with D? I've got Z, which is a product. So Z as a product wouldn't feature. It's reactants that feature in your rate equation.